So welcome. So this is CAI May June 2007 P3 paper. There are 10 questions, but the 9th question is from vectors. So we are not going to solve because it's based on planes concept, which has been deleted and is included in further math. So we're just solving only the 9 questions, excluding vectors. So the first question, 2 plus 3x whole to the power of minus 2, 2 plus 3x whole power minus 2. Remember, always here it should be 1. So I take 2 common, 1 plus 3x upon 2 whole to the power of minus 2. But most of the students, they do a common mistake is they don't write 2 power minus 2 because 2 is being pulled out of the bracket. So it should be 2 power minus 2. Then I should be doing it out. I should be doing the expansion for this one. So 1 upon 4 times a plus nx. N is minus 2, x is 3x upon 2, plus it is has been up to x squared. So only two terms, minus 2 minus 1 by 2 factorial, 3x upon 2 whole square, plus and so on. Okay. Now I can simplify this one by using the calculator. So let me pull up the calculator and do that one. So 1 upon 4 times 1 minus 3x, then 2 factorial and 2 gets cancelled. This is minus 3. 3 times 3 is 9. 9 times 3 is 27. 27 upon 4 x square, and so on. So my final answer will be 1 upon 4 minus 3 upon 4x plus 27 upon 16 x cube x square, and so on. That's going to be the answer for the first part of the first question. Question number 2. The polynomial x cubed minus 2x plus a is denoted by p of x. So let me write p of x is equal to x cubed minus 2x plus a. X plus 2 is a factor, means p of 2 should be equal to 0. So 2 cubed minus 2 times 2 plus a is equal to 0. So 8 minus 4 plus a, 2 cubed p of minus 2. So you have to be very much careful. P of minus 2. So minus 2. So minus 8 plus 4 is equal to 0. So I get the value of a as 4. So very careful. If x plus 2 is a factor, I plug in minus 2. Now what is the case? When a has this value, find the quadratic factor for p of x. So x cube minus 0x square minus 2x plus a is 4, divided by x plus 2. So I divide with x plus 2. So let us do x goes in x square. X should be multiplied with what to get x cubed? X should be multiplied with x square. X should be multiplied with x square. So I multiply with x square, it becomes x cubed plus 2x square. So minus minus cancels, minus 2x square minus 2x. So next time, let me erase this. X should be multiplied with what to get minus 2x square. X should be multiplied with what to get negative 2x square. So it should be negative 2x. So I multiply with negative 2x. So negative 2x square, negative 4x. Plus plus, it gets cancels, 2x plus 4. So let me erase this also now. Next time, x should be multiplied with what to get 2x. X should be multiplied with what to get 2x. It should be positive 2. So plus 2. So it becomes 2x plus 4. It becomes 0. So therefore, the other quadratic factor is x square minus 2x plus 2. That's going to be the answer. Question number 3. The equation of the curve y is equal to x sine 2x. Find the equation of the tangent. So first, what am I going to do? I'm going to find dy by dx. X sine 2x derivative, cosine 2x times 2. Then sine 2x as it is, x derivative is 1. Then plug in pi by 4 over here. So m is equal to dy by dx, add x is equal to pi by 4. Becomes 2 times pi by 4, cos times 2 times pi by 4, plus sine 2 times pi by 4. Cos pi by 2 cos 90 is 0, so 0 plus sin 90 is 1. So my slope is 1. X value is pi by 4. Substitute and get the y value 2. You have to get the value of y2. So y is equal to x, which is pi by 4, sine 2x, 2 times pi by 4. So y is also equal to pi by 4. So the point is pi by 4 comma pi by 4 and the slope is 1. So equation is y minus y1 is equal to m times x minus x1. So pi by 4 gets cancels, y equal to x. This is going to be equation. Question number 4. Substituting u equal to 3x, solve this one. If u equal to 3 power x, 3 power minus x will become 1 upon u. So substitute u equals 2 plus 1 upon u. So multiply by u, so 2u plus 1 upon u. So u square equals to 2u plus 1. I get u squared minus 2u minus 1 is equal to 0. It's a quadratic. Factorize minus b plus or minus b squared minus 4ac upon 2a. So it becomes 2 plus or minus square root of 8 upon 2. So now I get 2 roots, 2 plus or minus. So u is equal to 2 plus square root 8 upon 2. U equal to 2 minus square root upon 2. U is nothing but what? 3 power x. So when I do this one, this is 3 power x is equal to 2 minus root 8 upon 2. This is not possible because it's a negative number. 3 power x cannot be negative because what do I mean by 3 power x? 3 multiplied many times. Whenever you multiply 3 many times, you can't get a negative number. So not possible. So my 3 power x is equal to this. So for this, what do? Apply log on both sides. So I can bring this x in the front. Only x, not 3 power x. So I get the x. So oh, it's moving entire thing. So what do? I move this x in the front. X in the front. Because of log, that x can be moved in the front. Oh, that's very great. Because lack of space, or else I still try. Don't worry, I try like this. Maybe this one. Yes, x moves into the front. So now I want x value. So this log 3 also moves over here. So this becomes log 2 plus root 8 by log 3. So which value? X value, when I get it out, I do by calculator, 0.802. That's all. This is a final answer. Now coming to question number 5. So what is this? Question number 5 states that it states cos theta plus root 3 sin theta in the form of r cos theta minus alpha. So cos theta plus root 3 sin theta. So there is no number 1, so that's a and b. So a is equal to 1, b is equal to root 3. So r is equal to square root of a square plus b square, which is 1 plus 3, that is 4, square root of 4, which is 2. So what am I going to do? I am going to multiply and divide by 2. Multiply and divide by 2. What do I require it out? I require r cos theta minus alpha. So r cos theta cos alpha plus sin theta sin alpha. So I can see that with cos theta cos alpha should be there, with sin theta sin alpha should be there. So my cos alpha should be equal to 1 upon 2. Alpha is equal to cos inverse 1 upon 2, which is 60 degrees pi by 3. So it becomes 2 cos theta cos pi by 3, and root 3 by 2 is sin pi by 3, sin theta sin pi by 3. So it becomes 2 cos of theta minus pi by 3. That's the answer. So alpha value is pi by 3 and r value is 2. Now hence show that the integration is 1 upon 3. Integration 1 upon cos theta plus root 3 sin theta whole square. d theta from the limits 0 to pi by 2. 0 to pi by 2. So limit 0 to pi by 2, 1 upon cos theta plus root 3 sin theta is 2 cos theta. Okay, so it becomes 1 upon 4, 0 to pi by 4, 1 upon cos square theta will become secant square theta minus pi by 3 d theta. Secant square theta integral is nothing but what? Tan theta. So 1 upon 4 tan theta minus pi by 3 from 0 to pi by 2, not pi by 4. The limits are pi by 2. So plug in pi by 2. Tan pi by 3 minus pi by 2 is pi by 6 minus tan 0 minus pi by 3 is minus pi by 3. So 1 upon 4 tan 30 is 1 upon root 3 minus of minus plus root 3. So it becomes 1 upon 4 times 1 plus 3 upon root 3. So my final answer is 1 upon root 3. That's going to be the answer, and I think so that is only asked us to prove. Question number 5. Show that alpha satisfies x is equal to 2 sin x. What is this? The major part will be the area of the triangle AOB is equal to half the area of the sector. That part I wanted. So what am I going to do? I am going to take only that part. What is that part? Area of the triangle is half of the area of the sector. So that part. Area of a triangle is half times r square sine alpha. Area of the triangle. Okay. Now area of this sector. Area of the sector is half r square theta. Half r square alpha. But there is one word in between, which is that half. So half times, but and again one more the word is there, is. So this is means equal to. So I break down that word and I got it out. So from there I should be able to solve and get that one. So I simplify now. Half and half gets cancels. R square and r square also gets cancels. So I get sine alpha is equal to 1 upon 2 alpha. So alpha is equal to 2 sine alpha, or general equation is x is equal to 2 sine x. That's what has been asked us to prove. Verify by calculation that alpha lies between 1 by 2 and 2 pi by 3. So we have to verify by calculation it lies between 1 by 2 and 2 pi by 3. So my equation will be f of x is equal to x minus 2 sine x. Pi by 2 and 2 pi by 3. So substitute pi by 2, use the mode of the calculator in radians, 2 sine pi by 2 and pi by 3. Pi by 3, 2 pi by 3 minus sine 2 sine 2 pi by 3. So I quickly take the calculator, then I do if pi by 2 minus 2 times sine pi by 2 and I keep the mode of the calculator in radians. So I get for the first one negative 0.4, next time it is 2 pi by 3 minus 2 sine 2 pi by 3. So I get positive 0.36. So as f of pi by 2 and f of 2 pi by 3 are having opposite signs, root lies between pi by 2 and 2 pi by 3. Now show that this root converges to this part. show that if a sequencer is given by the iterative formula, it converges to the root of this equation. So the iterative formula has been given. So the iterative formula has been given. Let me add a page. Okay, so basically the formula he has been given is xn plus 1 is equal to 1 upon 3 xn 4 xn sin xn, 1 upon 3 xn plus 4 sin xn. He's telling that this converges to this one, x is equal to 2 sin x. So what am I going to do? First take away the subscripts, 1 upon 3 x plus 4 sin x, then cross multiplication, 3x is equal to x plus 4 sin x, then 3x minus x is equal to 4 sin x, then 2x is equal to 4 sin x, then divide by 2 on both sides. That's it. You get the answer. Now what is being asked? Last part. Use this iterative formula to take the initial value as 1.8, correct to 2 decimal places, each iteration in 4 decimal places. So he's asking us to do each iteration in 4 decimal places. So what is the formula? Iterative formula, xn plus 1 is equal to 1 upon 3 or 1 upon 3, 1 upon 3 xn plus 4 sin xn, and initial value of x is 0. What is the initial value of x? 1.8. You can take any value, but in the question it is gained 1.8, so we take 1.8. So I start with n is equal to 1, so I get x2 is equal to 1 upon 3 x1 plus 4 sin x1, so which is 1 upon 3 times 1.8 plus 4 sin 1.8. So because of lack of space, what I will do is I will directly write this one, cut, and 1 upon 3 x1 value, x1 is 1 upon 8 plus 4 sin 1 upon 8. So I take mode of the calculator in radians once again, so I keep on repeating because many students tend to do wrong over there. 1.8 plus 4 times sine 1.8, it gives me 1.90. Okay, 1.8985, 4 decimal places each iteration. So therefore the next take n is equal to 2, so x3 is equal to 1.3, 1.8985 plus 4 sine 1.8985, 8985. Go back and change in the calculator, 8985, so it becomes 1.8952. So I stop here itself only, because when I see 2 decimal places this becomes 1.90, 2 decimal places this becomes 1.90. So therefore alpha is equal to 1.90. As soon as it repeats, that's going to be the answer. That's question number 6 was that. Question number 7. I is equal to this much. Use the substitution u equal to root x to get this value. U is equal to root x. U square is equal to x. U square derivative 2u, du upon dx. X derivative 1. What I can do? Dx I move to the other side. So du is equal to 2u du is equal to 1 dx. Now I change the limits. Lower limit of x is 1. So u square is equal to 1, u is equal to 1. UL, upper limit 4. U square of x is equal to 4, u is equal to 2. So the limits will become 1 to 2. Now, what is that? Okay, so let me write it in this way. So let me copy this one so that easy to identify. I copy this, I paste this. Okay, I do it over here. the limits I did 1 to 2. Now dx is nothing but what? 2u du. So 1 upon, next is nothing but what? X. What is x? X is u square. Then 4 minus root x. What is root x? Root x is u. So I got the substitution. So I think so that's what he's been asked. So you can see that one u and u gets cancels. That's it. So it becomes 1 to 2, 2 du by u times 4 minus u. That is being asked. Now hence show that I is equal to 1 upon 2 ln 3. So for this one, what should I do? I should do the partial fractions. So I pull out 2 upon u times 4 minus u is equal to a by u plus b by 4 minus u. So 2 is equal to a times 4 minus u plus bu. So let u equal to 0. So 2 is equal to 4a, a is equal to 1 upon 2. U is equal to 4, 2 is equal to a times 0 plus 4b, b is equal to 1 upon 2. So what will be that one? 1 to 2, 1 upon 2 upon u plus 1 upon 2 upon 4 minus u du. So this will become 1 upon 2 ln u plus 1 upon 2 ln 4 minus u divided by minus 1. Don't forget to divide by minus 1 because derivative of minus u is minus 1. So from there, plug in the values. 1 upon 2 ln 2 minus 1 upon 2 ln 4 minus 2 is 2. Then substitute 1 upon 2 ln 1 minus 1 upon 2 ln 3. So that's cancels and I get 1 upon 2 ln 3. That's going to be the answer. Question number 8. The complex number 2 by minus 1 plus I is denoted by u. Find the modulus and the argument of u and u square. 2 divided by minus 1 plus I. So multiply and divide with minus 1 minus I. Minus 1 minus I. So 2 minus 1 minus I by minus 1 square minus I square. 2 minus 1 minus I by 2. So I get 2 gets cancels. So u is equal to minus 1 minus I. Modulus of u is square root of 1 square plus 1 square, which is root 2. Then where is this? So argument, x is minus 1, y is minus 1, so it comes in third quadrant. So this is minus 1 minus 1. So tan theta, so what does that becomes? Tan theta is equal to 1 upon 1, theta is equal to pi by 4. But always the angle should be with positive x-axis, so this angle. So it should be pi minus pi by 4, but I'm going in the opposite direction, minus. So minus 3 pi by 4. So I'm going in the clockwise direction, therefore angle is minus. So minus 3 pi by 4 is going to be the argument. That is for u. It's been asked for u square too. So u square will be minus 1 minus I whole square. So that will be 1 square plus 2 times minus 1 times minus I plus minus I whole square. So it will become u square. I will be getting it as 1 plus 2y minus 1. So it is becomes 2y, 0 plus 2y. So argument of u square is equal to modulus of u square will be 0 square plus 2 square, which is 2. Now argument. Where is this 0 comma 2i? 0 comma 2i will be over here on the y-axis. So therefore its argument will be pi by 2. So argument of u square is pi by 2. Over here argument of u. That's the first part. Sketch on an Argand diagram showing the points of intersection, points representing u and u square. We have already drawn. Once again we'll draw. Shade the region whose points represents the complex number which satisfies modulus of z is less than 2 and z minus u square is less than modulus of z minus 2. So once again we shall draw the Argand diagram. So I have drawn. So the first one, we know that it was minus 1 is over here. So this is minus 1, or minus 1, if I do that big, it may not be good. So I draw it as smaller. So this is minus 1. So this point is u, and u square was over here double 2. So what I do exactly to make it much more meaningful, I can, okay, so, and this is 2. This is u minus 1. Now one more is modulus of z is less than 2. Modulus of z is less than 2. So it is a circle with center 0, 0 and radius 2. I am going to draw a circle with center 0, 0 and radius 2. So this looks almost all okay. And the next one is given as sorry for that, coughing. Z minus u square is less than z minus u. Modulus of z minus u square is less than modulus of z minus u. So it's a perpendicular bisector, u and u square. And where is a perpendicular bisector? Let me draw in a perpendicular bisector. And the shading should be towards u square and inside the circle. So this is going to be the answer. Shading towards u square and inside the circle. So that completes question number 8. Before that, ending the question, draw x real and y imaginary, origin O. Then lastly, question number 10. Question number 9, as such, I told you it is not there. Planes move to further math, so we are not doing over here. So a model of height h is certain type of a tree that a time t years after the planted assumes that while the tree is growing, the rate of increase of the height is proportional to dh upon dt is proportional to 9 minus h whole power 1 upon 3. So take away that proportionality symbol, dh upon dt is equal to k times 9 minus h whole power 1 upon 3. Now t equal to 0, h is equal to 1. dh upon dt is 0.2. So 0.2 is equal to k times 9 minus 1 whole power 1 upon 3. From there I get k value as 0.1. So my equation will become dh upon dt is equal to 0.1 times 9 minus h whole power 1 upon 3. Solve this differential equation, 7 marks question, and expression h in terms of t. So what am I going to do? Bring this dt to the other side. Okay. So first I write it out over here. So bring this dt to the other side and this h upon 3 to this side. And arrange it out in this way. Then apply integral on both sides. So when I apply integral on both sides, so it becomes 9 minus h whole power minus 1 upon 3 dh is equal to 0.1 dt. So it becomes 9 minus h whole power 2 upon 3 upon 2 upon 3 minus is equal to 0.1 t plus c. Don't forget to write c. Now we go back to the question and see that the t values are given over here. T and h values. T is equal to 0, h is equal to 1. It has been given in the question. T is equal to 0, h is equal to 1. So minus 9 minus 1 whole power 2 upon 3 upon 2 upon 3 is equal to 0 plus c. C is equal to minus 3 by 2 times 2 power 8 power 2 upon 3. 4 from there. This is 4, 6. So c is equal to this is 4. 2 cube 2 so square 4 minus 6. So I got c equal to minus 6. So what is my equation? Minus 3 upon 2 times 9 minus h upon 2 upon 3 is equal to 0.1 t minus 6. But I need to make h as a subject. So 9 minus h whole power 2 upon 3 is equal to 2 upon 3 times 6 minus 0.1 t. Then 9 minus h is equal to 2 upon 3. I can multiply this one also. 2 upon 3 times 6 is 12 by 3 is 4 minus 0.2 by 3. If I multiply this one, 0.2 upon 3, it is 2 by 30, means 1 upon 15. 1 upon 15 t whole power 2 by 3 will become 3 by 2. So h is equal to 9 minus 4 minus 1 upon 15 t whole power 3 by 2. So when I move this 3 by 2 to the other 2 by 3 to the other side, it becomes 3 upon 2. And I do the color coding so that you can understand what I have done. 2 upon 3 times 6 is 4, and 2 upon 3 times 0.12 is 2 upon 30, which is 1 upon 15. That is the value of h. Find the maximum height of the tree and the time taken to reach after this height after planting. Maximum height of the tree. So we can see that 9 minus something will be always less than 9 or equal to 9 or equal to 9. So the maximum height is going to be 9. So when this maximum height is going to be 9, provided this value should be equal to, this bracket value should be equal to 0. So 4 minus 1 upon 15 whole t whole to the power of 3 by 2 should be equal to 0. So basically 4 minus 1 upon 15 t should be equal to 0. 1 upon 15 t should be equal to 4. T is equal to 60 years. Don't forget to write the units. Then lastly, calculate the time taken to reach the maximum, half of the maximum height. So equation what we got, h is equal to 9 minus 4 minus 1 upon 15 t whole power 3 by 2. Half of the maximum height was 9 upon 2. 9 minus 4 minus 1 upon 15 t whole power 3 by 2. So 4 minus 1 upon 15 t whole power 3 by 2 is equal to 9 by 2. So 4 minus 1 upon 15 t is equal to 9 by 2 whole power 2 by 3. So 1 upon 15 t is equal to 4 minus 9 upon 2 whole power 2 by 3. T is equal to 15 times 4 minus 9 by 2 whole power 2 by 3. Do by calculator, you should be getting it as 19.1. That's going to be the final answer. In that way, all the sums of this paper has been solved. See you in the next paper. This paper was, we go back and check what's that paper, May June 2007 P3. See you in the next paper.